Today's lesson is finding the area of trapezoids. We discovered what that formula was today in class, and we will write that down on our notes here in just a moment. I just wanted to show you what some trapezoids look like, because they're not always going to look the same. So here's this just traditional one. Here is a table. So if you remember, I have a table very similar to this in my classroom. This is a lamp. And if you're looking at this here is a trapezoid. But if you actually had the lamp in front of you, both of these sides would be kind of angling out. These are just different forms here of what a trapezoid could look like. And if you ever go walking on the pier, you should see little divots in the pier. And those, if you were to mold it or put rope around it or something, it would form a trapezoid right there. And then this is just a picture of a house with some mirrors or some windows that are also in the shape of a trapezoid. So just some images of trapezoids for you to look at. The one thing I want you to know about a trapezoid is that they have to have, in order to be a trapezoid, it has to have at least one set of parallel lines. So if we're looking at these trapezoids right here, okay, if you look at this top and this bottom, these are parallel, because remember, parallel lines never intersect. Now these two sides aren't parallel, but that's okay, because I only need one pair. Now if I'm looking at this trapezoid, okay, I have parallel lines here on this side. They're parallel because they never intersect, and this is a trapezoid because I have at least one pair of them. Now, technically, a rectangle is a trapezoid because it has to have at least one set of parallel lines, and it has two. So this is also a trapezoid. We wouldn't typically call that a trapezoid, we call that a rectangle or a parallelogram, but it is also a trapezoid. Okay, so let's review what the formula is for the area of a trapezoid. The area of a trapezoid, I'm going to show you two different ways. I'm going to show you a traditional way that you'll see it in most resources, textbooks, things that you look up. It looks like this: 1/2 the height times the sum of base 1 plus the sum of base 1 and base 2. So that means base 1 plus base 2. That is how you would see it traditionally written. Okay? Well, what I would like you to do, and what I think, same thing we did with our area of a triangle, is let's work to the way our brains work. So we're going to have the height times the sum of the two bases, and then we will divide that by 2. So this is very similar to what we did with triangles. Okay? I would recommend setting it up like this, but you are also more than welcome to set it up like this. Now, let's look at our two trapezoids that we have right there. So in order for us to use this formula, we have to understand where the H, the B1, and the B2 come from. Well, the two bases are our parallel sides to each other. So if I'm looking at this trapezoid here, I look for my two parallel lines. Well, here's one parallel line and here's another parallel line. So I'm going to name the top one base 1 and the bottom one base 2. I could have done it the other way around. It doesn't matter. And now, same as parallelograms, we have to find our height. So we drop it all the way to the top, all the way down to one of those bases, and then that would be my height. I could have also, if I wanted to, found my height this way by dropping it down from this side down to that base 1. Either one of those is our height. Now let's look at this one. Where's my base 1, where's my base 2, and where's my height? Well, once again, we look for our parallel lines. My parallel lines are on the left and the right this time. So either way, it doesn't matter. So let's call this one base 1 this time, and this one over here base 2. Now I need to find my height. Well, I have to do it from my bases. So you might want to draw the height here, but that's not really how tall my trapezoid is. So we're going to flip it over here on this side. So remember, so that flat side is horizontal here. And then I can drop my height line from the top of one base to the bottom of the other. And then once again, I also could have done it on the outside and gone from here all the way down to base 1. So either one of those would represent my height. Let's look at our first example. Here's my trapezoid. So first I have to realize, okay, well, what shape am I dealing with? Well, that's a trapezoid. So I'm going to write my formula. And once again, like I said, I'm going to use that formula dividing by 2 there. That's the area of my trapezoid. Okay, so now I have to go, okay, well, where's my bases? Where's my height? So remember, we look for those parallel lines. There's my parallel lines. So this one I'm going to say is base 1. And this one up here I'm going to call base 2. And then my height, still the same as triangles and same as parallelograms. I look at where does my height land on my base. Okay, so this 2 is my height. Now I need to plug all those numbers into my formula. So my area is equal to my height, which is 2, times base 1, which is 6, plus base 2, which we said was 3, all over 2. Okay. Now I can simplify using my order of operations. So I want to make it look like the triangle formula did. Because remember, when we discovered the formula for trapezoid, we realized that it turned into a big triangle. So this looks very similar to your formula for a triangle. So when I'm simplifying, I have 2 times 9, because 6 plus 3 gives me 9, all over 2. And then once again, we're going to say, oh, can I cross cancel anything? Well, yeah, I have a 2 on top and a 2 on bottom. So I have my final answer. The area is equal to 9 miles squared. Okay? All right, let's look at our second example. Looking at our second example, where's my base? Where's my height? Well, my parallel lines are here. So I know that this one is base 1, we'll call it, and we'll call this bottom one base 2. I look for my right angle, which is right here, so I know that 5 centimeters is my height. Okay, so we have a trapezoid. So once again, we need that trapezoid formula. Height, base 1 plus base 2, all over 2. Now I just take those numbers that I've labeled and I plug them in. So my area is equal to the height, which is 5, times base 1, which is 5, base 2, which is 7, all over 2. Now let's simplify here. So I have 5 times 12, because 7 plus 5 gives me 12, all over 2. We ask ourselves that lovely question, can we cross cancel anything? Yes, we can. 2 goes into 12 6 times. So I'm left with a 5 and a 6. So 6 times 5 is 30 centimeters squared is the area for that second triangle. Go ahead, take a moment and answer those next 2 on your own questions, and then come back and we'll move on to example 3. Okay, welcome back. Well, I meant to say example 2 is the example we're on. Now I give you a shape. I give you a trapezoid. Now you have to find all of them. You don't have any dimensions. Well, these are all unit squares. So we need to know, well, this is a trapezoid, so let's write the formula. Well, I know that the formula is height times the sum of the 2 bases divided by 2. So I know I need an h, a b1, and a b2. Well, let's go. Okay, well, I need my base 1 and my base 2. We look for those parallel lines here and here. So those are my base 1, and that's my base 2. Now to find the height, remember, that is that perpendicular line that goes from the top of the first base all the way down to the bottom base and forms that right angle. Okay, so this would be my height. And now all I have to do is count those unit squares. So for my base 1, I have 1, 2, 3, 4, 5, 6 units. For base 2, I have 1, 2, 3 units. And then for my height, I have 1, 2, 3, 4, 5, and 6 units. Now I just have to plug those numbers in. So I know the area is equal to the height, which we've already said was 6, times the sum of my 2 bases, so 6 plus 3, all over 2. That 2 will never change. Okay, so now I need to simplify. So I have 6 times 6 plus 3 is 9, all over 2. Once again, we ask ourselves, can I simplify? Yeah. 2 goes into 6 3 times. I have a 3 and a 9 left over. So I get 27 units squared is the area for that triangle, or for that trapezoid. Okay, let's look at example 3. It says you can use a trapezoid to approximate the shape of Scott County, Virginia. The population is about 23,200. About how many people are there per square mile? Well, here's good old Scott County, and they have highlighted this trapezoid. So we're just approximating, which means we're just going to make a nice guess with the information that we have. Well, they give us all of our numbers. They give us our base, they give us our height, and they give us our B2. So all we have to do is plug those numbers in to our formula for a trapezoid. So I have the area equals my height, which is 20 miles. Base 1 and base 2 is 15 plus 38 all over 2. And then I'm going to continue simplifying that. And I get A equals 20. And then I have 15 plus 38 will give us a total of 53 all over 2. And then, yes, we can cross cancel. 2 goes into 20 10 times. So now I have 10 times 53. So 53 times 1 is 53. And then I have to add 1 0. So the area of Scott County is 530 square miles. Well, the question is about how many people are there per square mile? Well, I know that there are 23,200 people, and I want to see how many people per square mile. Okay, so I have 23,200 people all over 530 square miles. That is people per square mile. So all I have to do from here is plug this into my calculator to find out how many people I can get per square mile. So I can get approximately 44 people per square mile. Okay, I'm going to do one more of these because I think these are a little bit trickier, just that last step. So once again, we have a trapezoid. They've highlighted that area out for us. Base, heights. Okay, let's use our formula. Area equals the height, B1 plus B2, all over 2. My area is equal to the height, which was 21 miles, and then 23 plus 19, or 19 plus 23, all over 2. Simplifying, I get 21 times, this is 42, all over 2. And yes, I can cross cancel, so 2 goes into 42, 21 times. And then you can get your calculator out and do 21 times 21, and you get the area is equal to 441 miles squared. Now, once again, it asks us how many people are there, so I need to do that same per square mile. I have to do that same thing. 32,000 people per 441 miles squared will tell me how many people there are per 1 mile. So if I divide 32,000 divided by 441, I get 72.5, so I get approximately 73. So I'm going to do a little squiggly line, approximately 73 people per mile squared. Go ahead and take the time and answer those last two on your own questions. Read number 4 carefully and really try to take your time. You should have some work shown for that. There shouldn't just be a simple answer. All right, good luck and have a good night. And make sure you take the time to ask a question at the very bottom of your notes. See you tomorrow.